Hi everyone, my name is Miss Duffy and I'm going to be your algebra teacher for Winter Break Academy. So this is our first lesson of Unit 1. Unit 1 is on quadratic functions, and this first lesson is just going to be introducing quadratic functions. So we're going to look at parts of the graph and then forms of their equations. Okay, so the graph of a quadratic is called a parabola. I don't know why my pen is being a little weird. Okay, so this shape is called a parabola, and there's a couple key parts of the parabola. So one key part is the y-intercept. So that's where the parabola crosses the y-axis. Okay. The parabola also crosses the x-axis, so we have 2 points in this case where we cross the x-axis, and we call those roots, or x-intercepts. Okay, the next key piece is called the vertex, and that's either the highest or lowest point on the graph. And then through the vertex, we can draw a vertical line, and that's called the line of symmetry. Because if we fold the parabola over that line, it will line up exactly with itself. So it's a mirror image of itself across that line. It's symmetrical. Okay, so let's practice identifying some parts of the graph. So the y-intercept, that's where we cross the y-axis, right? So it's going to be this point right here. So y-intercept is going to be, let's see, 1, 2, 3, 4, 5, 6, 7, -8. So you just say y-intercept is -8. Roots, that's where we cross the x-axis. So we have a root of 2 and a root of -1, 2, 3, 4. Okay, the vertex, that's our highest or lowest point, so that would be that point right there. So that's going to be -1, -9. We need to give both the x and y coordinate for that point. All right, and then the line of symmetry is the vertical line through the vertex. And we write the equation for vertical lines as x equals equations, because along this vertical line, x is always the same number. So no matter where you are on this line, x is -1. So the equation for that line is x equal to -1. And the equation for the line of symmetry will always just be the x coordinate of the vertex. Okay, so those are the parts of the graph. And in this unit, basically what we're going to be doing is connecting these parts of the graph to different forms that quadratic functions can take, their equations can take. So there are 3 different forms for the equations of quadratic functions. The first form is called general form, and it looks like this. Y equals ax squared plus bx plus c. A, b, and c are just numbers. And general form tells us the y-intercept of our parabola. So whatever this number c is, that's going to be the y-intercept. All right. Then we have a form called factored form, and that looks like this. Y equals a times x minus a number r1 times x minus a number r2. And factored form tells us the roots. So whatever r1 and r2 are, the numbers that you're subtracting in those parentheses, those are the roots. Oh my gosh, I don't know why it's doing that, I'm sorry. R1 and R2 are the roots. And then finally, we have a form that tells us the vertex, and that's vertex form. So it looks like this: y equals a times x minus h all squared plus a number, oh my god, k. And obviously vertex form tells us the vertex, so this number h and that number k, those are the coordinates of the vertex. All right, and one thing to be a little careful with here is in these parentheses we have x minus r1, but the root is just positive r1. And in this parentheses we have x minus h, but the x-coordinate of the vertex is just h. So the upshot here is we always flip the signs for x values, but we don't need to flip signs for y values. So let's make a note of that. Flip signs of x values, not y values. Okay, let's do some examples. So we're going to identify the form and what it tells us about the graph. So this form has two sets of parentheses, so that's going to be factored form. And factored form tells us the roots, right? So these numbers that we're subtracting inside the parentheses, those are the roots. So 4 and 6, we flip the signs for the x values. So positive 4, positive 6 are the roots. Next one, 12x squared minus 6x plus 10, that's in general form. And general form tells us the y-intercept. So this last number is the y-intercept. It's a y value, so we don't need to flip it. So y-intercept is just positive 10. Okay, this one, 7 times x minus 2 all squared plus 11. When you see that little squared there, that tells you that it's in vertex form. And the coordinates of the vertex will be 2 and 11. So it's x minus 2, but we flip the x coordinates. So our vertex is positive 2, but we don't flip y values, so also positive 11. All right, let's just do 3 more. So this one is also in general form. We're missing that x value, or that x in the middle, but that's just because the b value is 0. So this is still in general form. My cat is here now. And the last number, the number that's by itself, is our y-intercept. And it's a negative. We don't flip y values, so we keep it negative. All right, next one, we have the two sets of parentheses, so that's factored form. So this tells us the roots. And remember, we flip x values. Roots are x values, so we're going to flip them. So x plus 10, our root is minus 10. X minus 8, the root is positive 8. All right, last one. We have 21 times x plus 5 squared. That's telling us that it's in vertex form. And so we find the coordinates of our vertex. So the 5 and the 14, the negative 14 there. And remember, flip the x coordinate. So x plus 5, our x value will be minus 5. But we don't flip the y coordinate. So minus 14 stays minus 14. Coordinates of the vertex are minus 5, minus 14. All right, so that's a quick overview of the parts of a parabola and the forms of a quadratic function.